Hi, my name is Sai Devalapalli and I am a B2B marketing strategist and technologist. I'm here to talk about convergence that is happening in data analytics stacks. There has been a Cambrian explosion, if you will, of big data technologies. You have Hadoop-based systems, SQL and No-SQL systems, document storage systems, real-time stream processing systems, the list goes on. The core analytics stacks from various vendors are starting to look more and more similar, though the development environment and the tool sets offered by these vendors are quite different. Given this, it makes sense to talk about how these various analytics stacks are converging. Compute storage clusters, where compute is close to the storage, is still the key architectural paradigm for data analytics. So HDFS and columnar databases are the foundation for a lot of the stacks. MapReduce is interesting in the sense it developed a lot of hype when big data technologies were at the beginning of the hype cycle. But we're starting to see that the ecosystem is realizing that MapReduce is best suited for executing highly parallel workloads in batch mode. And not all analytics jobs can be modeled that way. Query engines that are built on MapReduce, such as Hive and Apache Drill, are starting to fall short compared to MPP systems. So a lot of vendors have decided to implement relational SQL engines on top of HDFS, and these SQL engines are optimized for OLAP type transactions. And the performance of these systems is actually compatible to MPP systems, but obviously the advantage is that these systems, these new systems, are running on commodity blade clusters. Hadoop added support for line speed ingestion of data into Hadoop clusters, but there has not been support for fast in-memory stream processing in earlier versions of Hadoop. A lot of vendors such as IBM, Pivotal, SAP implemented proprietary versions of in-memory stream processing because of this. And then you have boutique stream processing companies like SQL Stream, for example. Another gap in current analytics ecosystem is lack of strong and mature support for big data machine learning on a blade cluster environment. Most powerful machine learning algorithms are available in MATLAB, R, and Weka, but they only work on data that can fit in the main memory of one compute node. There are parallel machine learning tools such as Parallel R and Revolution R, but these tools are just starting to become more developer friendly. Mahout is interesting. Mahout is Apache's solution for machine learning, and it supports most of the basic machine learning algorithms. But Mahout runs on MapReduce, and not all machine learning algorithms can be efficiently mapped into the MapReduce programming paradigm. So to sum it up, I think that gaps in existing analytics stacks have been around fast in-memory stream processing and around machine learning. Spark is an open source data analytics stack from Berkeley that aims to address real-time in-memory stream processing, and it also provides constructs for distributed machine learning. So analytics stack vendors who did not invest in proprietary in-memory stream processing solutions are now embracing Spark. But vendors who have invested in proprietary in-memory stream processing solutions are waiting to see how Spark gets adopted by the ecosystem. Spark runs on HDFS, and it provides libraries for machine learning, graph processing, as well as Hive-like SQL interface called Shark. In essence, Spark is becoming the Apache version for real-time in-memory stream processing and distributed machine learning. Spark also supports online machine learning, where the hypothesis is constantly adjusted in real time using streaming data. So some examples of online machine learning are applications such as recommendation engines, ad serving engines, and so forth. As the predictive solutions mature in data analytics, I think online machine learning will become a key aspect of lifecycle management of predictive models. And I think this because lifecycle management of predictive models is key to ensure that these models don't go stale. And models do have a tendency to become stale if the environment under which the original hypothesis was created keeps evolving and keeps changing over business cycles. Another open source machine learning tool I think it's worth talking about is MadLib. MadLib is interesting in that it implements machine learning algorithms using SQL constructs. So essentially it can run on any ANSI compliant SQL engine that executes on a blade cluster. So MadLib is actually a good tool for offline parallel machine learning, and definitely something that I think would have some traction going into the future. Before we answer this question, we need to ask ourselves, what is considered the core of Hadoop? Is it just HDFS or is it MapReduce? If the core of Hadoop is HDFS, then the answer is Hadoop becomes an underlying technology for all the key analytics tools and frameworks from Apache, open source. There has been so much marketing effort invested in Hadoop, and the credibility of investors is at stake. So Hadoop will probably become synonymous with HDFS. In fact, I would be bold enough to suggest that going forward, the Spark stack will be considered part of core Hadoop offering, and I don't think MapReduce going forward is going to be considered part of the core Hadoop offering. Thanks for watching.